Hello, this is a tutorial on the arithmetic of equations. So when we talk about equations, we should consider them as a recipe. For example, I have the equation on the board. We have a hydrogen combines with oxygen to give us water. And we read these coefficients, okay, we read these coefficients, we can consider them moles. So for every 2 moles of hydrogen molecule, we combine 1 mole of the oxygen molecule, and that would result in 2 moles of water. Okay, so these coefficients, we can consider them as moles. We can read it as moles. We could also read it as molecules. 2 molecules of hydrogen combines with 1 molecule of oxygen yields 2 molecules of water. However, when using moles, that's going to help us convert to grams for mass and liters for volume. So here we have an equation. And again, we use these coefficients, the moles and the ratios of the moles in our chemical equation recipe. We can use moles and convert it to mass, grams. For example, we might, see how many moles we have of something. Let's say we have 2 moles, and we would need to get the molar mass of C2H2, and that would be as to 1 mole, and that would give us grams. So if we look at this, if we have 2 moles of C2H2, and we want to know how many grams that is, we would get the molar mass of C2H2, and we can figure that out by 2 times 12 is equal to 24 grams of carbon, and 2 times 1 equals 2 grams of hydrogen, and so we'd have 26 grams of C2H2, and that would be per 1 mole. Okay, so this would be the molar mass of C2H2. Okay, now we could also convert moles to volume if we're looking for liters. And we know for volume, the molar volume, 1 mole of any gas is equal to 22.4 liters. 1 mole of any gas is equal to 22.4 liters. So given these moles, we can also convert that to liters. So using the coefficient as moles, we can convert it to mass, and we can figure out how many grams of each reactant we would need to produce, grams of the product. Or we can use the moles to determine the volume, how many liters of each reactant we would need to produce so many liters of each product. So we'll look at an example. In this example, we're looking at the masses. Mass is grams. So we consider this here 2 moles of C2H2, and we want to know how many grams, so we convert moles to gram. We determined the molar mass is 26 grams of C2H2, and that's for 1 mole. And so we multiply 2 because we're interested in 2 moles. Again, we could have the moles cancel out. So 2 times 26 would be 52 grams of C2H2. Molar mass of oxygen, okay, it's 2 times 16, which is 32. And that's how we get this number here. And we have 5 moles of that. And we know 32 grams is 1 mole, and we have 5 moles, so it'd be 5 times 32, 160. Same thing with carbon dioxide. Again, to get the molar mass of carbon dioxide, we have 1 carbon, which is 12 grams, and we have 2 oxygens. Okay, so oxygen is 16, so that would be 32 grams of oxygen, and so we would have 44 grams of CO2, and that would be this number right here, 44. And water, again, we get the 18, oxygen 16, plus 2 grams of hydrogen, and so that'd be 18. And so at the end here, For our recipe, 2 moles of C2H2 combines with 5 moles of oxygen gives us 4 moles of carbon dioxide, 2 moles of water. Or we can look at it this way. We calculated if we have the mass of 52 grams of C2H2 plus 160 grams of oxygen, that would yield 176 grams of carbon dioxide and 36 grams of water. Notice grams are equal on both sides. Okay, grams are equal on both sides. The next one we're going to look at is volume. Now remember when 2 slides back, when we talked about this, when we convert moles to volume, we know 1 mole of any gas equals 22.4 liters. Okay, 1 mole of any gas equals 22.4 liters. That's what we're interested in. We have to remember that. So now we're looking at volume, and here we have our equation, the equation we were looking at. We know 1 mole of any gas equals 20, whoops, that's supposed to be 4. .4 liters. Okay, so again, we have the 2 here, and here's the 2 moles there. We can use it here. Two times 22.4. Okay, 2 times 22.4 gives us 44.8. Here we have 5 moles. It would be 5 times 22.4. Gives us 112, and so on. Again, here's 4 moles of carbon dioxide. 1 mole is 22.4 liters, and then we have water, which is 2 moles. And so here we calculated the volume. Okay, here we calculated the volume of the gases. We can combine 44.8 liters of C2H2 combined with 112 liters of oxygen, and that would yield 89.6 liters of carbon dioxide and 44.8 liters of water. So there's 2 ways to use the equation. We can determine the mass in grams or the volume in liters. Okay, I have a practice problem here. Calculate the mass of the reactants and the mass of the products. I have this equation here. This tells us we have 4 moles of NH3 combines with 3 moles of NO. Gives us 5 moles of nitrogen and 6 moles of water. So you can pause it and then play for the results. So you can pause now. Okay, I assume you hit play. So here is our equation. And in this case, we needed to find the molar mass. Okay, we found the molar mass of NH3. 14 plus 3 is 17. So we'd have 68 grams of NH3. NO, nitrogen plus oxygen, 16 plus 14 is 30. Grams of NO, and that's for 1 mole, and we have 6 moles, so it's 180 grams of NO. N2, there should be a subscript, we would have 28 grams. And H2O, we have 6 moles of H2O. Oxygen is 16 plus 2 is 18 grams is the molar mass of water, and that's for 1 mole, and we have 6 moles. So when we find the mass, we would have 68 grams of NH3 combined with 180 grams of NO, would yield 140 grams of nitrogen and 108 grams of water. Again, here we use the mass. We found the mass. Calculate the mass. And when we calculate the mass, we need to find the molar mass first. Okay, our next problem. Interpret the equation in terms of volumes of gas at STP, standard temperature or pressure. 1 mole of gas at STP equals 22.4 liters. And I could just write that here. 1 mole is equal to 22.4 liters. Okay, so we look at our equation. This is our recipe. And again, we look at these coefficients. That's the number of moles in our recipe. So you can calculate it and pause it now. Okay, you hit play. Here's our equation. And now notice all these. Okay, this here. 1 mole equals 22.4 liters. That's our conversion. I had mentioned that back here. And I'll put this up. Okay. And so what we would have here would be 89.6 liters of NH3 combines with 134 liters of NO, would give us 112 liters of nitrogen and 134.4 liters of water. And again, here we have the conversion, and all these conversions are the same. Because any gas, 1 mole of any gas equals 22.4 liters. They're all the same. Okay, I hope this short tutorial helps out on converting the moles to mass and moles to volume when we have an equation.